Okay, let's take a look at the sock problem. So again, here's the problem: 24 blue socks, 24 red socks. What's the minimum number of socks you need to pull out of the drawer so you're sure to have at least 2 matching socks? So please, problem solving process step number 1, understand the problem. A lot of issues here. A lot of people reading this and not knowing that I'm looking for exactly 1 pair instead of 2 pairs. That was one of the bigger issues I saw, not understanding that this is a practical problem and not a probability calculating problem. So things to look for there. A lot of students showed that they didn't quite understand the problem by the answers they gave and the work they had. If you watch my video, I made an organized list. I really made kind of a chart or table, splitting up what could happen at each step of the pull and realizing after 2 I wouldn't quite be done. That was a pretty common student heuristic, was to make an organized list where you list out all the possibilities and see that after 3 socks you for sure had a pair. I also had students use deductive reasoning, so basically you're looking at worst case scenario there. The worst case scenario is I have 1 of each sock, or 1 sock of each color after 2 pulls, but then after the 3rd pull, that 3rd sock has to match 1 of the first 2, even in the worst case scenario. Here's another way you could do it. So here's manipulatives along with inductive reasoning. What I did was I made 8 attempts. I used my manipulatives, my erasers represented the different socks, blue erasers for blue socks, and then orange erasers for red socks, and I pulled out until I had a pair. So you can see here, after all of my attempts, the most times it ever took me was 3 attempts. That makes this a pretty reasonable guess for how many attempts it would take to get a matching pair of socks. Remember, we always need to look back and examine our answer. Can we check our result? Does our result make sense? Can we check our argument? Could we get there a different way? Could we see the solution at a glance once we've got it? And can we use this on new or other problems? Have we learned anything new? There's a lot of problems out there like this, a lot of puzzles out there like this, and this is kind of an often overlooked part of probability. So in probability, we do a lot of calculation of how likely is this to happen. We don't always look at, so what's the worst case scenario? And that's what this problem is really asking. What's the worst case scenario if I wanted to pull socks at random out of this drawer?